Good morning. Today in LeetCode 75 we're doing longest zigzag path in a binary tree. You are given the root of a binary tree. A zigzag path for a binary tree is defined as follows. Choose any node in the binary tree and a direction. If the current direction is right, move to the right child. Otherwise, move to the left child. Change the direction from right to left or left to right. Repeat the second and third steps until you can't move in the tree. Okay, so zigzag length is defined as the number of nodes visited minus 1. So a single node would have a length of 0. So this one would have a length of 3. Got it. Okay, so this one has a length of 4 because 1, 2, 3, 4, 5. Okay. So we're going to need a recursive algorithm. We want to visit each node and check both nodes coming off of that node, and then return the maximum of that node or its children. So the length minus 1 means that I can always just return the node's children's length. That's very helpful. I don't have to count if it's not currently a zigzag path. Right? Or I don't count the last node. Okay. Let's define a helper function. Zigzag path. It's going to take a node. Let's not do optional. We'll do node tree node. Well, okay, if it's optional, then I return 0. But I need it to be different whether I get a, let's go not optional. And we'll take a direction, take go right, Boolean. And we'll return an integer. Okay, so the zigzag path is going to do some stuff, and then it's going to return length of the path. Okay, so, and if root.left left path equals 0, right path equals 0, if root is none, return 0. Actually, root will always be 1, so I don't need to worry about that. Okay, if root.left, then we're going to do zigzag path on the left. Root.left, and we'll do it to the left, so this is false. Left path equals. If root.right, right path equals zigzag path. Root.right is true. And then okay, so we get to count this node if we get to count this node if the next node coming up is opposite false or true, but I won't know that when I invoke zigzag path. So I probably just need to put that up there, and we'll return zigzag path on root. All right. Let's see, to figure the problem out, here, let's go, oh, is that, there it is. Dang. I was going to copy that into, let's do this, screenshots. And then Excalidraw. Okay, so when I invoke the function, I have this guy. My first step is to check the zigzag path going left. Check path left. There's nothing there. Second step is to check path right. Okay, so check path right means I go here, and then from here I want to go check path left. From here I have nowhere to go, so I return one. So right from here I want to do check path opposite, and then I can return 1. If 1 and opposite return 1, so here I return 0. Yeah. If opposite exists, return 1. Check path same. So I check to the right. I check the opposite. And then I want to check the same, which is right again. Check path opposite and return length. If opposite exists, we return length plus 1. Okay, so then we check the path that's the same. No, we don't return. We store length plus 1. Okay, from here we will check back the same and return the length. If same exists, then same length equals length. We don't add 1 in this case. Now we return the longest of opposite versus same. That's my plan. Okay, so zigzag path has to, the longest zigzag path has to check the path to the left and the path to the right. Correct? So we can do this. And then we return if right path is greater than left path, return right path, return left path. Okay, so that should be my startup code. Now, I want to check the path that's the opposite. So opposite length equals zigzag path. Okay. Opposite node equals node dot right if if go right, else node dot left. Same node equals node dot right. Oops. If not go right. Oh. Same node if go right. Else node dot left. Okay. Opposite length equals 0. Same length equals 0. If opposite node opposite length equals zigzag path opposite node not go right. If same node same length equals zigzag path. Same node, comma, go right. Okay, so we're checking the path, returning the length, and then we're going to go right here. I can just do +1. Here, I'm done. Now I need to just return the maximum of these two. So if opposite length greater than same length, return opposite length, return same length. Okay, let's test that. And we passed one. Okay, so what happened here? This tree, is that my original test case? Yeah, this is the test case I practiced on, so test result. Okay. Our longest, wait a minute, what's that ... about? Yeah, this is the same test case. So actually right here we have a 1 and then another 1. Okay, so our longest is this one, which is 3, and I returned 4. Oh, having different values is pretty terrible, or same values is terrible, because I can't really use the values for debugging. Unless I change the values as I go. That's possible. It looks like I'm just one off. Two. So what if wonder if it has no children. Maybe if I just added 1 here, but only if there is a node. Or if there is children. Right, because if there's, I can create a test case, can't I? So I'm wondering if there's only 1 or 2 nodes. Can I do that? No, it's not going to let me do that. Huh. If there's only 2 nodes, does this work? first of all, let's do this. +1, and then if node dot left is none and node dot right is none, return 0. Oh, this should be root in the main function. So, okay, I passed these tests. That's an edge case, so does it apply to all cases? I got a wrong answer at number 21. And this gotta be, this is ugly. View the entire tree. Okay. So there's supposed to be 6 as the longest. Let's say 1, 2, 3, 4. No. 1, 2, 3. No. I wonder where it is. 1, 2, 3, no. 1, 2, 3, no. 2, 3, no. Oh yeah. 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4. Yeah, I don't know where they get off saying there's a 6 in here anyway. Oh, my output was 6. It should have been 5. 1, 2, 3, 4. I don't even see that though. 2, 3, 4. 1, 2. No. Let's see. So we're back at the problem of I get to add an extra 1. What if the end node returns 1? Still fails this one. Okay, so to debug this, I have to figure out where that line is. 1, 2, 3. That's it. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. No. 1, 2. Huh. I don't even see this 5 path. Okay, well this is going to take extensive debugging, so see you later. So I'm back, and I've solved the problem. The problem I was running into before is that the first node can't tell if it should add itself or not, because it only knows what direction it came from, not what direction the good answer came from, or what direction the next node in the good answer was. So in this case, I'm passing down the length instead of returning the length. So we create a max length that's stored in the class, and then call zigzag path to the left of the top node with from right being false, and then to the right of the top node with from right being true. And since we know we have a top node in either case, the current length is 1. If there's only one node, then in both cases we return none and we never change the max length, which means the length is 0. If there's only 2 nodes, then we know the max length is 1, because you have either a left zigzag with a length of 1 or a right zigzag with a length of 1. And then if you have more than 2 nodes, then you get into the actual programming. So if this node is none, we return nothing. Do nothing, just get out of here, end the recursion. If it's not none, then we have to check if the current length, the one passed into this function, is greater than max length. So that's where you have 2 nodes, you're passing in zigzag path with a length of 1. The current node is not none, so we're going to increase the max length of 0, make it 1. And then if there's 2 nodes, then both of these will return without doing anything, in which case we're done. So then we have to check from right. Is the parent from the right node? Or is the parent passing down to the right, so, or to the left, so from right. If it's coming down from the right, that means that when we pass down to the right, we're still coming from the right, and we need to reset the length because we're not changing directions. Then we want to pass down to the left, which means we're not coming from the right, and we want to increase the length because we are changing directions. If we're not coming from the right, then do the same thing, just reverse it. And end the recursion after that. So this function actually does like 92% speed and 92% space. All solutions, submissions. There we go. 96% speed, 91% space. It only ever visits the nodes once. It ends early whenever it can. And the only extra space is the recursion stack and a primitive value. So, thanks for joining me.